premier air shows, and a real privilege to be here on behalf of the Boeing Company to introduce our newest airplane, the 787 Dreamliner. Now, my current job is actually program manager for the second member of the Dreamliner family, the 787-9. But as Scott said, I've actually been on the program and a member of the leadership team since the very beginning, about 10 years now. So I can tell you from the very start of the program, the 787 was about a lot more than just raw airplane performance. So we knew early on that we had a set of technologies with the composite structure, the more electric architecture, advancements that we've made in aerodynamics and flight controls to deliver just unprecedented performance in terms of payload range, fuel burn. But we were really about more. From the very beginning, we said, we want to address all the stakeholders of a new airplane. So where does that start, Scott? It starts really first with a passenger. All of us, the flying public. So I'll tell you in a moment about a set of technologies, really groundbreaking technologies, that we've been able to integrate into the cabin that really changes the experience for the flying passenger. So that's the first stakeholder. Second, obviously, our airline customer. And for the airline, it's really about productivity and ultimately profitability. So there again, it's really more than just performance. It's more than just payload range. It's more than just fuel burn. It's things like maintenance costs. It's things like pilot training costs, cargo capacity, residual values, flexibility, all the things that increase the productivity of the airplane for our customer. And then finally, it's about all of us, about our communities. And here I'm really talking about environmental responsibility. And of course, low fuel burn, lower emissions is a very big part of that. But there's more. There's also noise. Those of you who see the airplane or hear the airplane coming in or out, or don't hear the airplane coming in or out, it is an amazingly quiet airplane. So there's noise. It's quiet from the perspective of community noise, also ramp noise, and internally in the cabin. So a lot of what we talk about are some of the numbers, performance numbers, 20% reduction in fuel burn, 30% reduction in operating costs, but it's really more than just those numbers. Okay, go ahead. So I mentioned there are two members of the 87 family right now. The first, the recently introduced 787-8. Now the 87 is a 767 A330 size airplane. So it's got a passenger count for the Dash 8 of about 210 to 250, a range of about 8,000 nautical miles, a max takeoff weight of roughly 500,000 pounds, and cruises at just over Mach 0.85. Second member of the family is my personal favorite, the 787-9. This is the stretch version. So it's a 20-foot stretch, about 40 additional passengers, a max takeoff weight of roughly 550,000 pounds, and also cruises at just over Mach 0.85. So the 787-9 will enter into service in early 2014 with our launch customer, Air New Zealand. Okay. All right, let me talk a little bit about those technologies. The most obvious one everybody thinks about first is the composite structure. So if you look at the airplane from the outside, just about everything you see is advanced composites, most of it carbon fiber. Now the thing that is not as obvious under the skin is the systems and the systems architecture. So we've gone to what we call a more electric systems architecture. So in a traditional airplane today, you take high pressure, high temperature bleed air off of the engine to run many of the systems. Now what does that do? That, for one, degrades performance of the engine. It's also very difficult to deal with. So the pneumatic system that deals with all that high pressure, hot air, we've eliminated it from the airplane. Very heavy, very difficult to maintain, and basically just very inefficient. So the 87 has no pneumatic system, and instead we've got a very enhanced electrical power system. So between the 2 starter generators on each of the engines and the 2 on the APU, we can generate about 1.5 kilowatts, or megawatts, excuse me, of power on the airplane. So just a huge amount of electrical power capability on the airplane. So the airplane uses that electrical power to do many of the functions that you would normally use this hot bleed air or the hydraulics for. So things like compressing the air for the cabin, that's done with electrical air compressors. Anti-ice on the wings is electrical. Also engine start. It's an electrical engine start. We also have the industry's first electric brakes on the 787. Okay, now moving around, next is engines. So we've got the latest technology from both Rolls-Royce and GE. And these were engines that were developed from the very start of the program, knowing that we would have the no-bleed architecture. So both Rolls and GE were really able to optimize their engines around this new architecture. In terms of the flight deck, it's really an evolution of the 777 flight deck. We've incorporated all of the learning over the last couple of decades to make improvements to the flight deck, but fundamentally it is very similar in function to the 777, and that wasn't by accident. Back to our airline's profitability, many airlines will operate both the 87 and the 777. So we've actually been able to certify a common pilot type rating between the 87 and the 777. Very big deal for our customers who operate both airplanes. In terms of advanced aerodynamics, we use more extensive laminar flow across the airplane. Also, a number of improvements in terms of flight controls. So we have what we call maneuver load alleviation, where you use the flight controls to actually offload the structure during a maneuver, and it allows you to take out significant weight. So we've taken thousands, literally thousands of pounds out of the airplane by using this very smart flight control system. Also has gust suppression, which as a passenger will make even more difference to you because in a turbulent environment it reduces the turbulence and makes for a smoother ride. Then finally, there's a whole suite of improvements in terms of what the passenger will see. Go ahead, Scott. When you first go in, and you'll all have a chance here very shortly, the first thing you'll notice is a very spacious feel. So we've got the high ceilings, the advanced LED lighting, all contributes to giving you this very open feeling. The second thing you'll see are the very large windows. So the windows in the 787, because of the composite structure, we've been able to make them much larger. So they are between 30 and 50% larger than the windows that you have out there flying today. So large windows, also something that's a little different, is no more of those mechanical shades, or those shades that get stuck all the time. They're a real headache for the passenger and the airline. We've eliminated those altogether, and those little buttons you see underneath the windows are electronically dimmable windows. So you touch the button and it electronically dims or lightens the window. It can also be controlled by the cabin crew. And then in terms of seating, just a lot of flexibility allows our customers to use very quickly different seat layouts depending on their business. Okay, go ahead. Now probably even more important than what you'll see when you first go out there is what you'll feel if you're on a flight, particularly a long flight. So if you look at the top three up there, the lower pressure cabin, the increased humidity, and the cleaner air, those all really work together to make a huge difference in the way you feel when you come off of the airplane. The top two there, the increased humidity and the lower pressure, are really enabled by the composite structure. Because the composites really don't fatigue or corrode like typical aluminum can, we're able to reduce that pressure in the cabin and also introduce more humidity. We did a lot of studies early on, over a period of about 10 years, looking at the effect of pressure, humidity, and also air quality. Conventional airplane has what we call HEPA filters. They filter out particulates out of the air. What we've done on the 87 is we also include gaseous filters. So they can eliminate things like VOCs, volatile organic compounds. And so with that extra air purification, the higher humidity and the lower cabin altitude You really feel the difference, particularly after a longer flight. Okay, go ahead. In terms of the productivity and the profitability of our airline customers, just a number of areas here where we see improvements. The faster speed, I mentioned it cruises at just over Mach 0.85. Believe me, I came over here on an A340 in a very long flight. I wish it could cruise at just over Mach 8.5. So high speed, very, very good cargo carrier. The way the fuselage is laid out has excellent capacity in terms of cargo. Also, non-stop routes from the very beginning. We designed this airplane as a point-to-point airplane. So very good range, allows you to connect many more city pairs. I mentioned the flexible seating configuration, and then we really believe that as more and more 87s get out there, that it really will become a passenger preference. The airlines will see passengers asking, especially those frequent flyers, whether or not they're flying on a 787. In terms of operating costs, lower fuel efficiency, obviously. It's lightweight. The lower noise translates into reduced fees. Lower maintenance cost, another big advantage of the composite structure. So one of the biggest drivers in a traditional aluminum airplane to maintenance costs, especially later in life, is corrosion and fatigue. Lots of money spent by the airlines because of corrosion and fatigue. With a composite structure, those are much, much less of an issue, so the long-term maintenance cost is lower. Also, those more electric systems are generally much more reliable. They're also getting more reliable every year. Everyone is using electric systems. Nobody uses pneumatics in the way we use them or have used them in the aerospace industry. So we've gotten rid of a system that really is at the end of its life. We've put systems in, electric systems, that are very reliable and are getting more reliable every year. Now I mentioned mixed fleet flying with a common pilot type rating and 777. There's a big cost savings there, and the airplane just fundamentally is very standard. So you get most of the options that you really need and want as basic on the 787. Okay. Let's talk a little bit about the environment in terms of the environmental performance of the airplane. Obviously, lower emissions, very big deal, 20% fewer carbon dioxide emissions, and also lower for smoke, for NOx, and CO. I mentioned noise, community noise. So we meet the QC 0.5 and 1.0 for approach and landing at Heathrow. Very, very quiet airplane. I hope you get a chance at some point when you're here to be outside as the airplane comes in for a landing. You can see in the picture there those chevrons, kind of the little pointed things on the exit of the engine are part of the technology, the whole suite of technologies that really makes the airplane extremely quiet. Other improvements as well, reducing environmental footprint. Our new factory in South Carolina is actually a zero waste to landfill facility. So we don't send any waste from that facility to the landfills. And then also in terms of composite recycling, we're doing a lot of work right now. In fact, we have started an industry organization that's really focused on airframe recycling. Okay? All right, just a few words on the 787-9. I mentioned it's a little bit longer ranged airplane, about 300 nautical miles longer range. It's a 20-foot stretch, so about 40 additional passengers. And we've also learned a lot from our initial work on the Dash 8, and we've rolled that in to the Dash 9. In terms of improvements in the composite structure, lighter weight. So some of the structures are even lighter weight on the 787-9 and also lower cost. We met several big milestones over the last couple of years. Firm configuration in the middle of 2010. Just last year, the end of last year, we started building components for the Dash 9. So we are into production. We have first flight the middle of next year and then deliveries in the first part of 2014. Go ahead. Overall program status, you know we've started deliveries. Right now, big focus on ramping up production. We moved from the current production rates of 2 or 3 per month fairly quickly up to our max rates of 10 per month and possibly even higher. I mentioned the Dash 9 is progressing in its development and still see a very, very strong market demand. Go ahead. You can see that market demand here, about 870 orders across a very broad customer base. So very different than some of our airplanes in the past. A huge, very diverse customer base for this airplane. Go ahead. Okay, so